This week we're going to talk about factoring polynomials. We're going to start with some vocabulary review. These notes that I'm going to walk you through are from Unit 1 at the beginning of the course. We looked at some vocabulary that we're going to be using for this unit this week. The first thing we're going to talk about is a term. There are terms that are separated by plus signs and minus signs, such as this expression 2x plus 3 has two terms. The first term is the 2x and the second term is the 3, and they're separated by the plus sign. A monomial has one term. Some examples of monomials are 5x, or another one could be 3x squared, or 7xy. They are a monomial because there's only one piece in the expression. There is no plus or minus sign. A binomial has two terms, so it will have two pieces separated by a plus sign or a minus sign. This first one here is 5x minus 3, and here is another example of 7 plus 3x squared. A trinomial, these are the ones we're going to see the most this particular unit, and they have three terms separated by plus or minus signs. So here the three terms are the 5, the 2x squared, and the 9x. Polynomials just have one or more terms in an expression. The degree of a polynomial is the highest exponent in the polynomial. Here our example is 5x squared minus 3 plus 8x to the 7th plus 1003x. And so this has 1, 2, 3, 4 terms, and the degree is the exponent that is the highest among all those terms. So here the degree is 7, because 7 is the highest exponent that we see in this entire expression. Standard form is to write the polynomial in order where the highest power goes first. So to write this expression into standard form, the 8x to the 7 would be the first part. The next part would be the 5x squared because the 2 is the next highest exponent, followed by the 1003x because it has a power of 1, and then the minus 3 at the end because it has no x's at all. Here are a couple examples where we're identifying the degree. We are naming the as like a trinomial, monomial, binomial, and then we're writing it into standard form. So the first example is 7 plus x to the 5th plus 3x to the 3rd. To put them into standard form, you want to start with the x to the 5th. Then you would follow that with the plus 3x to the 3rd, and then the last piece would be the 7, as you can see the standard form here. There are three terms, so this is a trinomial, and the degree is 5 because 5 is the highest power that we see for the trinomial. Here we have two terms, so it is a binomial. The degree is the highest power, and the highest power is this 2 here. So the degree is 2, it is a binomial. And the standard form would be to put the negative 5x to the 2nd first, followed by the positive 8x. A third example here, you can see the different highlighting separates the terms of the expression. There's 1, 2, 3, 4, 5 terms. And so anything that has more than 3 terms, we just call a polynomial. And then the highest exponent we see is the 7. So 7 is the degree. And the standard form would be to start with the 3x to the 7th, followed by the next highest power, which is the 4x to the 5th, and that was a plus sign in front of that, so it has a plus sign. And then the next highest power is this degree, or the power of 3 here, so it's going to be negative 8x cubed following up. And then after that, this is a positive 7x, so plus 7x, and then the constant at the end with minus 2 at the end. There is one thing about degree that we didn't have in those samples, and I made an example of it here. So when you have a monomial, or even a term in your polynomial that you're looking at, if it happens to have multiple variables, you want to find the degree by adding together those exponents. So the degree of this would be 2 plus 8. The degree is 10. So it's kind of weird, and we don't see it very often, but I needed to add that in here because I know one of the questions on your homework is about degree of a monomial like this. So again, you just look at your exponents, and if it's in one piece like this, then the degree of that is the sum of those exponents.